you look at this case, when M1 was resting here, the pulley was here and M2 was hanging here. In this case, this is 90 degrees, but this is 0 degrees. So in alpha equal to 0 degrees and beta equal to 90 degrees. So we can put these values. Sine of 90 degrees is 1. Sine of 0 degree is 0. So this will become 0. This will become 1. So acceleration will become m2g by m1 plus m2. And for tension, again put alpha equal to 0 degree. This will make this 0. And this will make, we put beta equal to 90 degrees, that will become 1. So tension becomes m1 m2g by m1 plus m2. So we got the equation for this particular case also. In the third case, we had one inclined plane, but this angle was alpha. This was m2 and this was m1. So alpha is equal to alpha, right? And beta is equal to 90 degrees. So we can substitute in this equation. Alpha is alpha, beta is 90 degrees. So acceleration will be m2g minus m1g sin alpha by m1 plus m2. Again here we put beta equal to 90 degrees, this will become 1. So we get tension as m1 m2g 1 plus sin alpha by m1 plus m2. These are the equations that we got earlier. Now we have talked about pseudo force. Pseudo force comes into play only when we take an accelerated frame of reference. It is our choice. If you take an inertial frame of reference, no pseudo force will come into play. However, if we take an accelerated frame of reference, we have to apply pseudo force. So let us try to solve a problem by taking both an inertial frame of reference as well as an accelerated frame of reference. The final result will be same. We have got a triangular shaped block. This is called wedge. Say of mass capital M. A small block, rectangular block of mass small m is resting on this block. We are applying a force capital F on this block. The question tells us what is the value of capital F so that small m remains at rest with respect to capital M. Now, first we will take an inertial frame of reference. This means the observer is on the ground. Now, let us try to draw the free body diagram of small m with respect to an inertial frame of reference. That means with respect to the ground. Since this force is acting on this system and this is not moving with respect to this, both the objects will have an acceleration in the horizontal direction, say A. Now if you look at this small block M, mg is acting downwards. Normal reaction will act perpendicular to the surface. Any other force acting on this block? No. And the acceleration is in this direction. Now we have to resolve the normal force into two components. Look here. We draw perpendicular to this surface, draw perpendicular to this. This angle will be equal to this. This angle is theta. This is also theta. So if that angle is theta, this component will be n cos theta. And this component will be n sin theta. Okay, this angle is given to us. Now, if you look at this direction, say the y-axis, there is no acceleration, so all the forces must be balanced. Therefore, n cos theta must be equal to mg. This is equation number 1. If you look at the x-axis, only one force, n sin theta is acting, and that is causing an acceleration. So n sin theta must be equal to ma. That is equation 2. If you divide equation 2 by 1, we get tan theta equal to a by g. So a becomes equal to g tan theta. Now if you look at this entire system, a force capital F is acting on mass capital M plus small m. So the acceleration will be equal to force by total mass. So we get F equal to m plus m into a. Now a is g tan theta. The force required is m plus m into g tan theta. So this is how we solve the problem if you take inertial frame of reference. Now we are going to take an accelerated frame of reference. That means our frame of reference is wedge. Now observer is not sitting here. The observer is on the wedge. Now if you try to draw the free body diagram of small m, what are the forces acting on small m? Since it is having mass, mg will act vertically downwards. Normal reaction will act perpendicular to the surface. Any other real force acting on the system? No, these are the two real forces acting on the system. Now since our frame of reference is accelerated, we must apply a pseudo force. Pseudo force will act opposite to the acceleration of the reference frame. So this reference frame is accelerating forward. Pseudo force will act in this direction. And pseudo force is mass into acceleration of the reference frame. So m is the mass of the body under consideration, a is the acceleration of the reference frame. Please understand, this is the acceleration of this wedge. It happens that this acceleration is same as the acceleration of m, but you have to take the acceleration of the reference frame. So Fp is equal to m into a. Again resolve n into two components. This will be n sin theta and this will be n cos theta. Now in this frame of reference, this m is having no acceleration. So therefore n cos theta will be equal to mg and n sin theta equal to ma. We have got the same equations. So we will get the same results. So we can solve this problem either by taking an inertial frame of reference or by taking an accelerated frame of reference. When we take an accelerated frame of reference, we apply a pseudo force in addition to all real forces. Pseudo force is given by mass of the body under consideration multiplied by acceleration of the reference frame. The direction of pseudo force is always opposite to the direction of acceleration of the reference frame.